grade 11s, welcome to your first lesson officially online. So what I'm doing now is just recapping your grade 10 trigonometry, and then we'll be moving on to some grade 11 trigonometry in the next video. I also have an older video from last year sometime that I'll also put up of grade 10 work. It might be quite similar to this, but at least you can have rather double up, have more than less. All right, so when we start with trigonometry in grade 10, we teach you just the basic idea of sine, cos, and tan. So you will hopefully remember these ratios here. Now, I don't know what poem your teachers taught you last year. There are different ones. And then there's SOHCAHTOA, there's different ones, but I like, oh hell, another hour of algebra. And you always remember it goes sine, cos, tan. All right, you can also use the idea of if we draw on a Cartesian plane. So if we draw it like that, okay, that will be a y, an x, and we call this an r because it actually comes from a radius of a circle being drawn around there. But don't worry about that for now. All right, so we have a right angle triangle. You only learned about right angle triangle trigonometry, and we're going to keep it that way until term 3, where we're going to introduce non-right angle triangle trigonometry. But it's super nice and super easy. All right, so if I were to go from this angle, we call it theta. We use Greek letters for angles. Sometimes we'll use an X, a Y, a P, but most of the time we're going to use a theta, an alpha, a beta from the Greek alphabet. All right, so if we're going to go with sine, it's opposite over hypotenuse. So remember, your hypotenuse is always across from your right angle, and so that is y over r. And then cos is adjacent over hypotenuse, which is x over r. And then we have your tan, which is opposite over adjacent. So that's where we get these pieces from here. All right, let's just erase this. Okay, so that's where we're getting these pieces from. And in order to work it out, I like a little poem called Shield. That's how you spell shield. Good start. Shield your rear, cause X rays tan your exterior. And that comes from, so sine is y over r, cos is x over r, and tan is y over x. So that's just another little trick to remember it. Or what you can do is just draw a little triangle for yourself and work it out. All right, so you must know your right angle triangle ratios, opposite, adjacent, hypotenuse, sine, cos, and tan. And also something that you know quite well, you must know your Pythagoras. All right, so Pythagoras, please note, is not a squared plus b squared equals c squared. It's just saying that whatever two sides you have that are not the hypotenuse, it's actually your hypotenuse squared is your side 1 all squared plus your side 2 all squared. Right, so it's not always going to be a, b, and c. It's going to be categorized according to the triangle you're working with. Okay, and then you also learned about basic quadrants in grade 10. So what that just means, for those who forgot, we have a Cartesian plane. Okay. And we start off labeling at 0. Then we go anti-clockwise. 90 degrees, 180 degrees, 270 degrees, and 360 degrees. There's your angles around a point. All right. So then we talk about, this is quadrant 1, quadrant 2, let's use a pen rather, quadrant 2, quadrant 1, quadrant 3, quadrant 4. All right, and we're going to come back to using this quadrant quite a bit. Now, the little poem or little saying I want you to remember is all students talk crap. So all of the ratios, sine, cos, and tan, are positive in this first quadrant. Only sine is positive in the second quadrant, tan is positive in the third, and cos is positive in the fourth quadrant. And I want to explain why that is. Alright, so let's just get rid of all that. Okay, so do you agree that here the x values are positive because that's where we'd be on our scale, y values are positive. As soon as we go to the left of the y-axis, our x values become negative and my y values become negative. Imagine using a piece of graph paper. Alright, so if I were to draw my little right angle triangle in here, right, if I were to do opposite over adjacent, it would be positive, because that's a y value, because it's going upwards, over positive. So positive and positive. Now, just a note, please, your hypotenuse is always positive because it's representing a radius of a circle. It's a measurement. We can only get positive measurements. So in the first quadrant, your y over x, your r, all of those are positive values. But as soon as we go into quadrant 2, my x's are negative, my y's are positive. So any vertical is positive, but any horizontal is negative. My hypotenuse is always positive. So if we were to go opposite over hypotenuse for sine, we're going to get positive over positive. But if I'm going to go adjacent over hypotenuse, so adjacent over hypotenuse, I'm going to have a negative over a positive. So the cos adjacent over hypotenuse is going to be negative. If I were to go opposite over adjacent, opposite for tan over adjacent is going to be positive over negative, is negative. So the only one that gave us a positive answer was when I went opposite over hypotenuse, positive over positive. All right, so it's just important to recognize that piece. So if we go into the third quadrant, my y is negative, my x is negative. But my hypotenuse is still always positive. So then from this corner here of the triangle, if we go opposite over hypotenuse, sine is going to be negative. Negative over positive. If I were to go adjacent over hypotenuse for cos, cos is going to be negative. But then if I'm going to go opposite over adjacent, it's going to be negative over negative for tan, which is a positive. Negative and negative make positive. So only tan is positive there. In the last quadrant, same thing. We're going to have a negative y, a positive x, positive hypotenuse. So opposite over hypotenuse, sine is going to be negative. If I do adjacent over hypotenuse though, positive over positive, cos is going to be positive. If I do opposite over adjacent for tan, we're going to have negative and positive is negative. So that's why each of these quadrants have their own specific kind of like zone for each of the ratios. So in quadrant 1, all of them work. They're all positive. In quadrant 2, only sine is positive. It's sine's territory. For tan is only positive in the third quadrant and cos in the fourth quadrant. Please, this is really, really, really important to remember when you are working with the grade 11 stuff we're going to go into. All right, then just recapping one last sort of theory bit, and that is talking about special angles. Now, the way some of you might have been taught is with a triangle. The way I was taught way back in high school was with this method. It was a table method, and it gives me something called a rationalized denominator. In other words, there are no roots in the denominators. But in the other method, which some of you might have learned last year, you get some roots in the denominator. It really doesn't make a difference which one you use. Your calculator will naturally give you the denominator that has been rationalized like that. In other words, it gets rid of the root at the bottom. But it's fine because you're not supposed to use a calculator for special angles, but I personally wouldn't need to use a calculator with my method, but I still get the calculator answer. So I'm not going to go in the detail of how we find our special angles. If you really cannot remember them or can't figure them out, then please use a calculator, but we don't want any decimals and we don't want to know that you've used a calculator. So you must always give it in fraction form for those that are fractions. In other words, we don't want to see for, let's say, cos of 30, which is root 3 over 2, we don't want to see this 0,866, for example. We want to see the fraction. That means you've used the calculator if you've used the 0,866. I won't know if you've used the calculator if you've given me the root 3 over 2. Right, so just be smart about it if you are not so great at remembering your special angles. All right, the last thing you learned in trig, besides the trig functions, which we'll come back to, is the Pythagoras type questions. All right, so if you've forgotten what I'm talking about, it's the type where you have to draw a diagram and see which quadrant you're working in. So here's the example. It says if 13 sine theta equals -5 and theta is an element from 90 to 270 degrees. These are your clues. Your clues. Apologies here. It shouldn't be -15. It should be -5. All right. Just cross it out. -5. So your clues. So let's get sine by itself. So sine theta is going to be equal to -5 over 13 if we bring that along. That is your first clue. So we're going to be drawing on a Cartesian plane. Right? So you need to ask yourself, where is sine going to be negative? So that was the first clue, is helping us to see sine is negative. So remember your little rhyme, all students talk crap. So sine is going to be negative, not in the A, that's all. Sine is positive in its own one, so it must be in tan and cos's quadrant. Then we've got to go to the second clue. The second clue is telling us something about the angle. It says it's got to be between 90 to 270. So we start at 0, can't be from 0 to 90. Oh, but it can be from 90 to 180 and 180 to 270. Can't be beyond 270, it stops at 270. So it means the double tick is working in tan's quadrant. Okay, so we have our right angle triangle there. You always start from the origin, work your way diagonally outwards up to the x-axis to draw your triangle. All right, so then here our hypotenuse will be positive, our x value must be negative, our y value must be negative. Don't forget that. And our angle is actually this big angle here, because it's telling us it's actually an angle that is not acute. It's bigger than 90. And in this case, it's actually it's a reflex angle going beyond 180. So we actually just work with it as if it's acute within there. And when we get into the grade 11 stuff, we'll talk about how we can just assume that a small angle and a big angle can work together. All right, so we've worked out that sine theta is -5 over 13. Now remember, sine is opposite over hypotenuse. So opposite from that dot is going to be the -5, and your hypotenuse must be positive 13. So now we have to work out what that third side is, and we do that by Pythagoras. So we're going to be working with 13 squared, our hypotenuse squared, is equal to our x squared plus our y squared. Okay, or you can rearrange it straight away and make the x squared the subject of the formula. Please make sure you put the -5 in brackets so it's also squared. So it becomes 169 minus 25 is 144. And when you square root x squared, you square root the 144, it's plus minus 12. Because both positive and -12 can square to get 144. But look at your quadrant. Our x must be negative, so therefore x is -12. So your triangle actually looks like this: -12, -5, positive 13. All right, so then the question is not the drawing. It's the whole point of this is to get down to this piece. It says, with the aid of a diagram, find the value of cos theta plus sine theta. So, get rid of that. Cos theta plus sine theta. Now, the point of this is to get rid of the cos and sine completely. So, put brackets straight away and remind yourself that's adjacent over hypotenuse, that's opposite over hypotenuse. So, cos adjacent from that point is negative 2 over hypotenuse is, not negative 2, negative 12 over hypotenuse is 13. Plus my sine is opposite, negative 5 over hypotenuse 13. Remember, your hypotenuse is always across from your right angle. So in this case, we're going to get an answer of negative 17 over 13. If you need your calculator for it, please use it. All right, so no sine, cos, or tan left over in these types of questions. Okay, so that's pretty much, besides the trig functions, that's what you covered in trig last year. You also worked with angles of elevation and depression, which kind of come in a little bit later, but not too much for now, more in term 3. So this is pretty much what you have to get your head around. So I'm going to be starting in the next video the grade 11 stuff. I'm going to be going slowly with it. But what you need to just recognize is the Pythag questions. Again, I'll lead you through them. And you must remember all students talk crap, your quadrants. You must remember your ratios. Another hour of algebra. And then you must remember your special angles of 0, 30, 45, 60, and 90 degrees. All right, if you can recognize those things for now, then you'll be fine going into the new stuff. All right, grade 11s, please watch the next video for the start of the grade 11 work.